Hi, welcome back to the Network Plus Certification video series. I'm Mike Redmond, Master Trainer, here to help guide you through your successful journey of becoming a Network Plus certified technician. We're going to walk through a wide variety of topics, starting with basic network concepts all the way through network management and security. In this segment, we're going to take a look at network naming. I'll describe the functions and capabilities of DNS, show you how to configure and troubleshoot WINs, and explain the use of some common TCP/IP utilities to diagnose problems with DNS and WINs. So, as I like to say, the best place to start is always the beginning. Computers use IP addresses to communicate. People remember names better than numbers. So to solve this, we need to figure out how to get people to think like a computer. Well, for that, we need some help. We use name resolution. It was created to convert names into IP addresses and back. Name resolution has evolved over the years. The primary protocol used for name resolution is DNS, or the Domain Name System. Operating systems support both old and new versions of the DNS, regardless of the operating system, whether it's Windows, Linux, or Mac. Windows, for instance, uses a version called Windows Internet Name Server, or WINS. We'll talk more in detail about that later. So let's start with taking a look at DNS. Early internet use used what was called the host file. It was one file copied to all hosts on the internet. It contained a list of IP addresses for every computer matched to the system name. The host file preceded any type of DNS that you and I might know today. Anyone could name a computer anything, and the only real rule was that duplicate names were not allowed. So below you see what an average host file would look like. And like clockwork, if you forgive the pun, the host file was updated on every system every morning at 2 a.m. However, this quickly became impractical as the internet continued to grow. A new naming system had to be developed. Now understand that there are still host files in existence today, and you can find those on your computer. As a matter of fact, every operating system is still configured to look for the host file first. As a matter of fact, the host file is just a flat text file. It's completely editable. Some people even place shortcut names in their host file to avoid having to type long names into their browser. DNS is really much more powerful than the simple host file. With DNS, still no single computer can handle all internet name resolution, so it's delegated. You have what's identified as a top-dog DNS. The system delegates parts of the job down to subsidiary DNS systems. All DNS servers, however, run a special DNS server program. So, now that's the basics of the hierarchy of DNS. The naming system facilitates this delegation. The top-level DNS is the most powerful, and there are several of them dispersed around the world, known collectively as DNS root servers. The internet name for DNS root is dot. Below the root, you have top-level domain servers. Whereas with the host file, we used a flat namespace, DNS uses a hierarchical namespace, a hierarchy of DNS domains and computer names, if you will. The hierarchical DNS namespace is called the DNS tree. Root is the holding area for which all domains connect. Individual computers have host names under the hierarchical order. Now, it is possible for you to set up your own domain server. There's no rules against that. However, it's generally not going to be allowed to connect to the internet, but for practical purposes, you could set one up for your own organization. So within DNS, there are certain rules that must be followed, starting with the DNS naming syntax. It's kind of opposite from the folder directory syntax that you're used to. With DNS, we call it the FQDN, or the fully qualified domain name. Hosts and all domains in order are listed with the FQDN, with the root being to the far right. So if I were to set up my own personal DNS, it might look something like this. Or if I had an organization that I needed to set up a DNS structure, it might look like this. So now that you know the nuts and bolts of it, there's a few more items that you should understand. Some key players, if you will. Starting with the DNS name server. That is running the actual DNS software itself. The DNS zone is a container for a single DNS domain that gets populated with records. And a DNS record is simply a line in the zone data that maps an FQDN to an IP address. Name servers, or authoritative DNS servers, serve a single domain. Other name servers then are subordinate to the primary. All DNS servers know the address of the start of authority and all name servers in that domain. So the start of authority really keeps the others updated. So how do other DNS servers learn about each other? Well, they query each other. They make requests, if you will, to resolve the fully qualified domain names to unknown IP addresses. So for instance, an internet naming scheme would start to look a lot like this. You have the root at the top, and then the top level domains. You're familiar with them as .mil, .net, .com, .org, .edu, and .gov. Underneath there are your individual domains owned by your organizations, and then subdomains underneath them. Most people probably wouldn't even use the internet without domain name servicing. Much of this has really become transparent to us. We've gotten so used to opening up a web browser and typing a name, and then that name just resolves to the correct IP, and voila, we have the web page that we were searching for. So to understand how that works, you need to understand the three basics of how to resolve a name. It can either be done through broadcasting, through the host file, or through querying the DNS server. So an important point to understand here is that routers do not forward broadcasts. So when trying to query a web page on the internet, remember I told you there were three options: broadcasts, host files, or DNS. And since routers don't forward broadcasts, well, you'd never get outside of your own organization. This is why it's important when populating each client in your organization, there are the four must-haves. Every client must have a unique IP address. It must be assigned a subnet mask. It must have a default gateway. And it really should have at least one DNS server, two for a backup. Simply by typing ipconfig/all, it will show you, for instance, on a Windows machine, all DNS information in the command line. So, as I mentioned, most modern OSs are going to have built-in DNS server software. You'll have to be running the server versions of those operating systems. You have server versions of Windows, and most versions of Unix support this capability. Within every DNS server, there are three special storage areas. First, the cached lookup. Second, the forward lookup zone. And third, the reverse lookup zone. For instance, in Windows, this is a Windows server screen, you see these three main areas. And by drilling down into them, for instance, this is the cached lookups, you can see the resolution for every known server. Now, it is possible to have a what's considered cache-only DNS server. They do not store, for instance, lookup zones. They do, however, talk to other DNS servers to resolve for their clients. They are never considered an authoritative server for a domain. They're just simply there to relieve the overall pressure for the primary domain controller. Each system in the domain has what's called an A record. The alias for a system is, simply put, the CNAME. For SMTP services or email, you'll notice MX records. And with the advent of IPv6, you'll see Quad A records. So with your forward lookup zones, you have two types, the primary zone and the secondary zone. They both resolve for the FQDN, remember that stands for fully qualified domain name, exactly, to the IP address with what's called the reverse lookup zone. So a little bit about the Windows DNS server. It does perform most functions exactly like the Unix and Linux DNS servers. It adds a Windows-only Active Directory integrated zone, though. This is to avoid the problems of standard DNS servers. Understand that all domain controllers are DNS servers, and all DNS servers are equal. This is because in the 1980s, Microsoft used a technology called NetBIOS and NetBEUI. In 1990, Microsoft created NetBIOS over TCP/IP, and then added NetBEUI naming to DNS. It's an old sharing protocol that used the server message block. With NetBIOS over TCP/IP, along with it came a new sharing protocol, the Common Internet File System, or CIFS. SMB and CIFS were adopted by Unix and Linux and then eventually Mac. CIFS and DNS, well, they work hand in hand. Networks using CIFS use basically two naming systems. CIFS broadcast to find the local server. DNS queries then find the TCP/IP host. So with these two naming systems, it's organized in a rather ingenious way. CIFS organize computers into work groups. Your computer joins a work group. Now again, this is going back to the convention of host files with using a flat namespace. But that's okay because it's only in your local area. You can find the workgroups, as a matter of fact, by going to Network and then My Network Places. Computers that are controlled by a Windows Domain Controller server are grouped in a Windows domain. Windows computers that have joined that domain authenticate, usually by username and password, to the domain. Windows domains, as a matter of fact, now use DNS. So at its heart, an Active Directory domain is an organization of computers that shares one or more Windows domains. All Active Directory Windows domain controllers are, in fact, DNS servers. And while on the internet there is a top-dog DNS, all domain controllers are actually equal partners. So, a little more about Active Directory. You'll have another zone to think about, as I indicated, which is the integrated zones. You see, DNS information is stored in the Active Directory database instead of text files. So Active Directory is stored across several domain controllers, so there's no longer only one copy. This is for fault tolerance and redundancy. The domain controllers automatically replicate each DNS zone information along with other AD updates that might need to happen. That brings us to a concept known as dynamic DNS. See, DNS previously required manual updates to all the zone files. This became very problematic as the internet and organizations continued to grow. With dynamic DNS, it enables a DNS server to talk to a DHCP server and get IP addressing information for its own clients. Most all modern DNS software is capable of dynamic DNS. Windows clients can also use update DNS server files automatically. With the advent of always-on high-speed connections at home, your home computer can now run as a web or file server and enable remote connections to it. The problem with this is now you have the existence of home or office router-assigned DNS names. Dynamic DNS maps the home or office router to a specific DNS name. This way, if the router's external IP address changes, this often happens with ISP providers that do not give you a permanent IP address, but rather hands them out by DHCP, it notifies the dynamic DNS server, and then it makes the updated change. This allows your home or office network to be connected via a domain name, regardless of your actual IP address changing. Next, let's take a look at how to troubleshoot some problems with DNS. Understand that the client is usually the source of most all DNS problems. DNS servers, they're workhorses. They very rarely go down. If a DNS server is down, clients then just simply use a secondary DNS server. So when you get the symptom of server not found error, the best place to start looking is at the client's DNS cache. When going into the client's DNS cache, the best first step is to do what's called flush the DNS. You can do this in Windows by going into the command line and typing ipconfig /flush DNS. The next thing to do is to go into the command line and ping a well-known website like Google or Microsoft. Does it return an IP address? If not, try pinging the IP address if you know it. If the previous steps indicate that you do have a problem with DNS, the next thing to do is run the NSLookup utility. What this does is it queries the functions of the DNS servers. Now, of course, this requires you to have the proper permission levels because it's used to basically change how your system uses DNS. To run NSLookup, you'll need to know certain parameters. IP addresses and name of default DNS servers, for instance, and any errors that indicate primary DNS server is down or client has the wrong IP for the DNS server. Next, if you're using a Unix or Linux machine, very similar to DNS, would be the tool known as dig. It's non-interactive. You just simply ask it a question and it answers. You might have heard people refer to digging DNS. The Network Plus examination expects you to know and understand how to use both NSLookup and dig. Next, let's take a look at diagnosing TCP/IP networks. Again, understanding that it's usually improper configuration that causes most of these problems. Ping anyone you want to connect to, and you should get an answer. Regardless of what the user cannot connect to, you need to perform the exact same steps. When troubleshooting, it really all does start with common sense. If one system behaves differently than others, the problem is with the system, not with the underlying network. So before starting any of the troubleshooting steps that we're going to talk about, you should check the network connections first. So the basic steps to troubleshooting TCP/IP, it all starts with diagnosing the NIC. Then we'll move to diagnosing the local client, and then we'll check IP addresses and subnets. Next, we'll run netstat with no options, and then netstat -s. Then we will diagnose the gateway, and finally, only then do we begin to diagnose the internet. A nice next step would be to run the traceroute command. This will let you know not only if you can get to the far end connection, but what hops it's taking to get there. Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry, I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time.